Hey guys, we're going to do some of these even ones on the multiple choice just to clear up any confusion. I think the multiple choice are always really important because that's what they look like on the test. So let's do it. Your homework is to do this problem set for the assignment. And I actually put a little notepad here on just the multiple choice questions so we could take a look. Okay. So question 33, you have the answer in the back, but I wanted to give just a little bit of information, right? It says George's score was 64th percentile. Where would that fall? So if I think about a box plot, this is the 25th percentile, the 50th percentile, the 75th percentile, right? And that's our quarter 3, and this is our median. So I'm going to pick C, the 64th, would fit somewhere about there. That would be George's score in the box plot, right? All right, question number 34. This really gets at the heart of the lesson we were working on. How does the mean and standard deviation change when we add or subtract? So thinking and looking back on our notes, we can see how important this is. Let me just mark this off. If we think about this, we noticed in class that when we add or subtract a number, then the mean subtracts by that and adds or subtracts by that number. Right? And when we add or subtract by a number, the standard deviation stayed the same. And for that matter, the shape stayed the same. But then when we multiplied or divided, the mean also multiplied or divided by whatever that number, by that number. So I think we were dividing by 10. So the mean divided by 10. And then the standard deviation actually changed. The standard deviation actually, when we multiplied or divided, it divided by 10. So the standard deviation did not stay the same. It multiplied or divided by whatever that number was. By that number. Okay. So I think that's what 34 is getting to the heart of here. It says when Sam goes to a restaurant, the server, he gives a tip, $2 plus 10% tip. If Sam's meal usually costs $9 with a standard deviation of 3, what is the mean and standard deviation of just the tip? So let's look at the mean, though. I think this might be important to understand the question. If I think about the mean is $9 plus or minus $3. So $9. Standard deviation is $3. So the tip, they said he automatically pays $2 more, right? So that means $11 plus or minus an extra 10%. So if 10% of 9 would just be 90 cents, right? 10% of $9 is 90 cents. So on average, he's going to be paying a total of $11.90 for a typical meal. But how much of that was the tip? Well, when we think about this here, the $2 was the tip and the 90 cents were the tip, right? So on average, the tip should be $2.90. So that's why I've focused my efforts on A and B, because again, they've just asked what would be the tip. So the tip on a typical bill would be $2.90. Okay. Now let's figure out what would be the standard deviation of the tip, just of the tip. So that actually, it's kind of easier to see how the standard deviation would change by just playing it forward. So a typical, like if you were one standard deviation above the mean, then your bill would be $12, right? Oh, sorry about that. So on a $12 bill, right, you'd still have that $2 tip, and you'd still have 10% on the original. So you'd have $1.20 of your 10% on top of that. So again, if I think about, well, how did the tip change? The tip only changed from $2.90 to $3.20. So on a typically higher bill, it went from $2.90 up to $3.20. That's not that big of a change. I could subtract that and show you it only went up by 30 cents. And so the same would be true if it was one standard deviation cheaper than usual, it would go down by 30 cents. So my standard deviation of my tip is actually 30 cents, and that's my choice there. This is my answer here. Again, I could also use my notes. Instead of actually working it out mathematically, using my notes, let's take a look. It says the standard deviation does change when I multiply or divide. So my standard deviation of $3, if I add $2, well, standard deviation is not going to change because adding doesn't change. But this multiplying by 10%, when I multiply $3 by 10%, I get that 30 cents. And so that's another way to think about my answer there. All right. 35 says, scores on the ACT entrance exam followed a bell shape with a mean of 21 and a standard deviation of 5. Okay, so a mean of 21 and a standard deviation of 5. Wayne's score was negative. What was his actual score? Okay, so this is kind of an Algebra 2 question. Wayne's score minus 21 over 5. And we know Wayne's standardized score was -6. So we can actually substitute that here. That's his z-score, right? And so we can multiply 5 on both sides, and we get -3. And we can add 21 on both sides, and we get 18. And again, that makes sense. He was a little below the mean, but not by a full standard deviation. So a full standard deviation, his score would have been a 16. So this actually makes sense. All right, 36. It says George's average bowling score is 180, and he bowls in a league where the average is 150 and the standard deviation is 20. So I need a little bit of room here. George's score is 180, and the average in George's league is 150, with a standard deviation in George's league of 20. So our formula, we could find out the z-score by taking 180 minus 150, divide by 20. Okay, so George is pretty good at bowling. He's 1.5 standard deviation above the mean. Now we're going to work with Bill. So Bill scores 190 in a league where the average score is a little bit higher. So we need a z-score here because in raw score he's higher, but we want to know relative to the league who's higher, right? So Bill's score 190 based on the average in Bill's league is 160, and the standard deviation in Bill's league of 15. So using the same formula, right, we get 30 over 15, which is 2. So Bill's actually 2 standard deviations above the mean. So Bill has should be ranked higher in his league because he's actually more successful in his league. 2 standard deviations versus 1.5 standard deviations. All right, last 2 questions. Let's take a look. It says, what is the interquartile range of these absences? So the interquartile range is Q3 minus Q1, which is our 75th percentile take away our 25th percentile. So using our pointer, 25th percentile looks like 2, 75th percentile looks like 5. So we're going to do a little math. 5 minus 2 is 3, okay? Now it says, if the distribution of absences was displayed as a histogram, what would be the best description of the shape? So this one you may have had to read a little bit in your textbook or think this through. So let's think about this as a box plot. I'm going to try to write a box plot on here. Our first quarter would be here. So this would be the front face of my box, right? And there's my minimum. And then my median is at my 50th percentile. So it looks like my median would be about at 3. So that's the center of my box. And we said our 75th percentile is about 5. So that's the edge of my box. And then this one goes way out here. So notice this looks skewed right, because we have lots of values that are way high, and that would move the mean to the right. So I'm going to actually draw that. Here is Q1, right? Here's my min, 50%. Q2, that's my median, 75th percentile, Q3, and then this would be my maximum. So this would give me this would be my box plot. And we don't typically actually look at shape very distinctively unless it's extreme. On a box plot, it's better if we look on a histogram, but if we think about this here, the first 25% of the data is in this range, and then they're cramming another 25% in this range, which would squish it up higher. This one looks a little bit more like the first range. And then think about it, the same area that I've written in these other 2 ranges, I'd have to spread out over the rest of this range. So our histogram would look something like that. And imagine that's definitely going to be right skewed. So I'm going to put skewed right, and I'm going to wish you a wonderful weekend. Go Bucks.